So these notes cover simplifying, multiplying, and dividing rational expressions. So a rational expression is a quotient of two polynomials. And we've talked about what the definition of a polynomial is. So we have examples of three different rational expressions: 10 divided by x, x squared minus 4 divided by x plus 2, or x plus 4 over x plus 2. All of these are examples of rational expressions. We can simplify rational expressions just like we simplify normal fractions. So say we have the fraction 10 over 25, right? We would simplify this. We know that 10 is 5 times 2, and 25 is 5 times 5. And now here, since we have 5 divided by 5, this divides to 1, right? So we're just left with 2 over 5, right? So we can use the same concept to simplify rational expressions by factoring the numerator and the denominator and then dividing any common factors out to 1. For example, if we have x squared minus 2x minus 3 divided by x squared plus 5x plus 4. So we want to simplify and identify x values for which the expression is undefined. So we know an expression is undefined when you have to divide by 0. So to find where the expression is undefined, we need to figure out where the denominator is going to equal 0, because you can't divide by 0. But first we need to factor both the numerator and the denominator. So what multiplies to negative 3 and adds to negative 2? Did you get it yet? This should factor to x minus 3 times x plus 1, and the denominator would factor to, did you get it yet? I hope so, x plus 4 times x plus 1. Now, right now it's easy to see the variables, or the x values for which it's undefined, so it's whatever's going to make these factors equal 0. So we have x cannot equal negative 4, and x cannot equal negative 1. Now, we also notice the numerator has an x plus 1, and the denominator has a factor of x plus 1. Since they have that factor in common, we can go ahead and simplify that. That divides to 1, and we're left with x minus 3 divided by x plus 4. And this would be simplified. So next thing we'll do is multiply two rational expressions. And we're going to multiply them just like we multiply fractions. So let's say we have 2x squared y to the 4th over 3x times 15x to the 4th over 10x cubed y to the 5th. Now, as you do more and more of these, you'll come up with shortcuts for simplifying them. You'll start simplifying before you multiply. But since this is the first one we're doing, let's go ahead and just multiply it like you multiply a fraction. So we go straight across. 2 times 15 is 30. And then we multiply x with x, so x squared times x to the 4th. We know if we multiply numbers with the same base, we add the exponent. So that's x to the 6th, and then y to the 4th. We don't have anything to multiply the y by. All over, now, 3 times 10 is 30. x times x cubed is x to the fourth, and we don't have anything to multiply the y by. Okay, now that we've multiplied, we can simplify this fraction because there's common factors. 30 divided by 30 is 1, right? So this just cancels out, divides to 1. X to the sixth over x to the fourth, if you have the same base and you're dividing, you subtract the exponent. So that gives us x squared. And then y to the fourth divided by y to the fifth, subtract the exponents, and that is y to the negative 1. And if you remember from the last time we talked about negative exponents, if you have a negative exponent, it's the same as having a positive exponent in the denominator. So x squared over y to the positive first power. And since it's to the first, you don't really need to write it. So this simplifies to x squared divided by y. Now let's do one with a polynomial that's just in x. So we have x plus 2 over 4x plus 16 times x plus 4 over x squared minus 4. And let's multiply and identify x values for which the expression is undefined. So the first step anytime you're dealing with something like this is completely factor. So we want to completely factor each of these. X plus 2, there's nothing we can do with that. But 4x plus 16, we notice these are both divisible by 4. So the x plus 2, I'll just rewrite. 4x plus 16, I can factor out a common factor of 4 from each of those terms, and I'm left with x plus 4. Again, x plus 4 in the numerator here you can't factor that any further. But x squared minus 4, you should recognize, factors to x plus 2 times x minus 2. And from this point, I can go ahead and start simplifying. I know that if it helps you to write this, then by all means do. But we don't want to start actually multiplying the polynomials together yet, because it's a lot easier if we simplify first. X plus 2, x minus 2. So now we want to identify common factors. So, divide out common factors. So I notice there's a common factor of x plus 2 in both the numerator and the denominator, and a common factor of x plus 4. So all of these are dividing to 1 when I cross them out, and what I'm left with is nothing in the numerator, which, remember, these divided to 1, so I'm not left with any variables in the numerator, but it divided out to 1. So I'm left with a 1 in the numerator, and this is all divided by, and I'm left with 4 times x minus 2, which, if you like, you can distribute the 4, and you're left with 1 over 4x minus 8. And there's the simplified version of this polynomial multiplication problem. So now let's do a division example. So divide. We have x to the 5th minus 4x cubed over x squared minus x minus 2 divided by x to the 5th minus x to the 4th minus 2x cubed all over x squared minus 1. Looks kind of scary. You guys are going to hate me. Now, step 1. Division, if you're dividing fractions, we rewrite as multiplying by the reciprocal. So, what does that mean? I'm going to change this to a multiplication, and this is going to become the reciprocal, which really just means it's the multiplicative inverse. I'm flipping the fraction upside down, right? So I'm going to erase this and just write it like this now. Remember, the first one doesn't change at all. So now in the numerator, I have x squared minus 1. In the denominator, I have x to the 5th minus x to the 4th minus 2x to the 3rd. But it still looks ugly because we have all these x to the 5th powers. Now, it's multiplication, so we completely factor. These are the same steps as multiplication at this point. And then we're going to divide out the common factors. Now this x to the 5th minus 4x to the 3rd looks kind of scary. But I know these are both divisible by x to the 3rd. So if I factor out x to the 3rd, then I'm left with x squared minus 4. Right? We'll go ahead and leave the rest of them alone for now. Now this denominator also has a common factor of x to the 3rd because the lowest power x is raised to is the 3rd. So I'm going to do the same thing I did with that other numerator. So it's x to the 3rd times x squared minus x minus 2. Okay, it's starting to look a lot less intimidating. Now there's still a lot more factoring I can do. So x to the 3rd is going to be left alone, but x squared minus 4, you should recognize factors to x plus 2 times x minus 2. Right? This is divided by x squared minus x minus 2, and I can factor that to x minus 2 times x plus 1. This numerator I can factor to x plus 1 times x minus 1. Uh-oh. And then this part of the denominator over here can factor, again, it was the same as this one, right? X minus 2 times x plus 1. Okay, now I can look for all of the common factors. So, it's really easy to get tripped up here. See, because I already forgot about this x to the 3rd that was in the denominator, right? Really easy to get tripped up, right? Right? So, what do I have in common? I see x to the 3rd, so that's going to divide to 1. Do I have an x plus 2 in the denominator? I do not. I do have an x minus 2 in the denominator. Now I have 2 of them actually, but only one of them is going to cancel, right? Only one of those pairs divides to 1. Same thing here with x plus 1. One of them divides to 1, but the other one stays there. So, to look real careful to see what I'm left with. I have, in the numerator, x plus 2 and x minus 1. And in the denominator, I have x minus 2 and x plus 1. So altogether, I'm left with x plus 2 times x minus 1 over x minus 2 times x plus 1. And at this point, it is completely simplified. If you want, you can multiply the polynomials in the numerator and denominator, but overall, this is a more useful form to work with. Okay, that's going to conclude this video notes. Probably what you recognized right now is that you need to practice your factoring, right? So remember, there are factoring video notes you can go back and review. So I hope you do that.